Hi guys, welcome to Programming Knowledge. This is Tanis Singhania and
Today we will be learning about the perceptron algorithm. It is an introduction to the neural network basic algorithm to start with the neural network. So it is a classification algorithm. So we will see what is the classification problem first. So let us take an example. There is a student who wants to get accepted in a university. So does he get accepted? So the university accept its his test scores and the grades. Both are out of 10. So say let's take an example of this point. So if the person gets 8 out of 10 in test and 2 out of 10 in grades, so he seems to get accepted in the university. So what about a student with test score with 7 and 6 grades? So he will lie around somewhere around here. Yeah. So he will lie around here, and I think he might get accepted. So we want to form a boundary line, a linear line, which will divide the blue points and the red points, and a few misclassified points. That is not an issue. That is an error. We have to minimize the error, not too much. We have to not completely minimize it to avoid overfitting of the data. But yeah, that is a complete uh, completely satisfactory result. So we will find a boundary line that is w1 x1 w2 x2 plus c. Now c is a constant, we can say it as a bias, and w1 w2 are the weights, and x1 and x2 are the parameters we input into as test and grade scores. So we can calculate a score out of this, and if the score is greater than 0, that means the point lies in this region, so the student gets accepted. If it is less than 0, it gets rejected. Pretty simple. Now we can also say the boundary line as wx plus b in the form of matrices. So we can say it as a 1 cross 2 matrix and a 2 cross 1 matrix of matrix. So if we multiply it, we can get a 1 cross 1 value, and we add the bias to it, so we can form a boundary line in the form of matrices. Same thing, nothing. Now what about higher dimension? Say the university accepts class rank also. So we will form a 3D plane, 3D, and a plane would divide the blue points and the red points, and we can form three parameters w1 w2 w3, and x1 x2 and x3 would be our input values. So again, same equation we will form wx plus b, and same score greater than 0, we say the label as 1, except less than 0, 0 will label, and reject. So what about if there are n dimensional space, n parameters? So what we will form? We will form an n minus one dimensional hyperplane basically. So we cannot visualize it. So we have written the equation here. So w1 plus x1, w1 into x1, w2 into x2, w3 into x3, and dot 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 wn to xn plus some bias. So same equation wx plus b. Now this time it is 1 cross n into n cross 1 matrices. Same scores, same thing, but we cannot visualize this dimensional hyperplane. So Perceptron algorithm. So what it does is, in this same example, we will take the scenario. So what a Perceptron wants is a test and grades. We will assign some weights to it, and get some calculation and assign if the student gets accepted or not. Basically, the boundary line. Now, what we did was calculated the score wx plus b. Now, why not we assign the b as input only? We can take 1 as the input and b as the one another weight. And if there are n inputs, we can take n inputs, w1, w2, w3, wn would be the n weights, and b as one of the biases, as one taking the input. Okay, and we could calculate the score and decide if the student gets accepted or not. Now, another thing. Now, what we have do is we assign the labels 1 and 0. We can calculate the labels too by the step function. If the values the score is greater than 0, we can say the step function would give 1. If it is less than 0, it would give 0. So one label would say the student gets accepted, 0 would say rejected. Now, perceptrons are of we can see the two types of perceptron, and perceptron and or perceptron. There are other perceptrons also. So, what an and perceptron is basically, there are a few points 0, 1, 1, 1, 1, 0, 0, 0. Now, and perceptron would draw lines like this, and it would accept 1, 1, 1, 1, and reject all these 3 points. You can see from the table, and or would accept these 3 points wherever there is a 1, and every other point would be rejected. So pretty basic stuff, nothing great. So there's a perceptron trick to it. So consider this is a graph. Okay, this is a line. Okay, this is the red region and this is the blue region, and this point was misclassified. It is actually in a red label point, and lies in the blue region. So what would it say to the line? It would say that come closer to the point. So if the line comes closer to the point, the line would eventually pass over the point, and the red region would increase and would correctly label the point. Now, for example, say this is the line. Now, I can assign all the weights and the bias like here, and if there is a point, say 4, 5, this point, so we can say 4, 5 and assign a 1, and multiplied by learning rate. Learning rate is nothing but we have to take the small steps towards finding the right line. Okay, then we will subtract it if we want to get the red region going up. If we will add it to increase the blue region. Nothing too fancy here. Now let us look at a pseudocode applying that trick. So we will start with some random weights, W1, W2, W3 up to Wn, and a bias. And for every misclassified point, we will say if the prediction is 0, that is actually it was 1, but we predicted 0. So we will uh, add some value into the weights and the bias as seen in the trick. If it is 1, we will reduce it.
That's all for this video. In the next video, we will implement this algorithm.